Okay, so with this quadratic function, this is in what is called a vertex form. The vertex form of a parabola is in this form: f of x is equal to a x minus h squared plus k, where the vertex of the parabola is h and k. Now notice you do change the sign with that. So the first thing we're going to go ahead and do here is say that the vertex of the parabola is -3 and -4. So do be careful with those signs. So the vertex of our parabola is over here at -3, -4. Now there's nothing written out front here in the original place. There's nothing for where this a is, but in this case that a is understood to be a1, and when a is greater than 0 or positive, that graph opens up. So I know this parabola opens up. Now, I will always ask you a couple more questions about these kind of parabolas. I want to know what the x-intercepts are and the y-intercepts. So to go through and find the x-intercepts, what you always do for this in this kind of question is just let y is equal to 0. What this means in this case is I have to solve this function. X plus 3 squared minus 4 is equal to 0. Now there's a couple ways to go ahead and do this. You can go ahead and multiply all of this out if you wish, but I'm going to solve this using the square root property, and I'm going to add 4 to both sides. Then that leaves me with x plus 3 quantity squared is equal to 4. I take the square root of both sides. Now remember, we have 2 possible answers when you do this, so make sure you take that as going to be plus and minus the square root of 4. So now I have 2 equations. The first equation is x plus 3 is equal to, that was a positive square root of 4, and the square root of 4 is just equal to 2, so I'm just going to leave it there. And then the other equation that I had was x plus 3 was equal to negative. And that is, again, because whenever you take the square root of an equation, you have to take the positive and negative. Now solving both of those equations for x, I subtract 3 from both sides, and I'm left with x is equal to -1. And the other one I have is, again, subtract 3 from both sides, and I get x is equal to -5. Now, those are the x-intercepts. I can write them this way, but remember, an x-intercept is always a point. -5, 0, and -1, 0. So I'm going to go back up to the top of my graph and plot those. As I said before, I always also want the y-intercept for these. How do you find the y-intercept? To find the y-intercept, you just plug in 0 wherever you have x. So let's just go ahead and do that up here. And that just becomes 0 plus 3 quantity squared minus 4. So that becomes, inside here becomes 3 squared, which is 9, minus 4. So all of that is just equal to 5. So that point gets up here. Now this is symmetric. Parabolas are always symmetric along that vertex. So try to imagine an imaginary line right here down the center of that parabola, and you can copy that over. If you notice, I am 1, 2, 3 units away from that line of symmetry, so that would be 1, 2, 3 units away right there, which will give us another point here at -6. And now I can go through and draw my parabola in. Now, what is the domain for this parabola? The domain is all real numbers. The domain goes from negative infinity to positive infinity. The range of this parabola, I've talked about range before. When you're talking about range, always think about this. I'm going to do this in yellow. Goes from where the point is over to the y-axis. So what part of this y-axis is being covered? And notice with this, it is going always up. The lowest value of my range was right here at -4. That -4 is included. So that becomes, the range goes from -4 to positive infinity. Be mindful that the lowest value always goes first when you're going through and doing the range.